Welcome, and in this lesson, we're going to learn about nice, renice, and niceness. So niceness is really just a way that I'm going to refer to the nice level of a specific process. What the nice and nice level does, it allows us to define a priority for a specific process. So for example, let's say that we have our HTTPD Apache process running, and it's on our server, and our server acts as a web server. That might mean that we want to give priority to all HTTPD processes. The reason we might want to do that is to ensure our application executes as quickly as possible. So what I would do is I would say, okay, Linux, I'm going to set the niceness of a specific process. I can either set it to -20 for the most favorable or 19 for the least favorable. And you can think of it like this. Think of it in terms of priority mail versus regular snail mail or express mail. So you send a letter in the mail and it's going to have a regular priority. It's just going to get there when it gets there during regular time. But we can send next day mail, which means it gets there faster. So that process, that mail item, will take priority and go essentially through an express process to get there faster. And that's what we're doing, is we're basically saying, hey, this process needs to have more priority when it comes to CPU utilization. That means the CPU will give priority to those processes. Now, this is really just a suggestion for the Linux kernel and the CPU. It doesn't always abide by it exactly, but this is how we're going to use a way, or this is how we give a priority to a process. And a lot of times we might want to do this to make a process complete that much faster than it would have if we set the priority lower. So to demonstrate this, let's just go ahead and create a quick file. If I take a look, if I do a df-h, it looks like I have about a gig available. And I'm going to go ahead and do a dd. We're going to set a if of dev0. Our location will just be our root directory, and we'll call it a test.file. Now, what I'm going to do is I'm going to set the byte size of this to 1 megabyte, and I'm going to set the count to 1024. So we're going to create a gigabyte size file. And one way that we're going to demonstrate nice is I'm going to launch the tar command, which is going to compress or create an archive of this file. So this file has been completed. If I navigate into my root directory and I do an ls, I see that we have our test.file. Now, what I can do is I can launch, using nice, a program to start it. So before we compress this, I'm going to go ahead and do a systemctl stop in my HTTPD process. And I can start my process with a higher nice priority. So for example, if I start HTTPD and we use the ps command we learned in the previous lesson, we're going to look at the process ID. Let's look at the command that started it and the nice level. And let's go ahead and grep for HTTPD. We see that HTTPD is running with a process or nice priority or niceness level, however you want to word it, of 10. So let's say that we want to increase these processes, or we want to increase the priority that our HTTPD program, any process that the HTTPD program starts, we want to increase the priority it has for CPU processing. So one way I can do that is I can actually start the program by using nice. So I can say nice. I'm going to give it a nice level. That's what -n stands for. And we're going to say, let's give it a 0. Now, one thing to remember for niceness is that the lower the level, the higher priority. The higher the level, the lower priority. So it goes from -20 to most favorable to +19, which is least favorable. So I'll do a nice, give it a nice level of 0, and let's start the HTTPD service. So let's see, it says it's already running. Let's see if in fact it did it with the nice priority. So I want to make sure that we kill. So systemctl stop HTTPD. Let's see if there's any more HTTP processes running. There is. So let's just make sure we kill them all. I'm going to do is pkill. I'm going to kill every single HTTPD process. Now let's check it again, and there's nothing there. So now if I want to start the program with a niceness of 0, the HTTPD process, any other process that our HTTPD program starts will have this same niceness level. That's why I may want to start the program with a specific niceness. So I'm going to say start this program with a niceness level of 10, and that's our HTTPD program. So now if we take a look at all of the processes that are associated with it, you see that we have a nice level of 0. Okay, so, well, I want to change the process priority of all processes that are owned or HTTPD processes. But I don't want to stop the HTTPD service in order to do this because that'll boot my users from the web server. So how might I do this? Well, I can use a command called renice. What renice does, it allows us to renice a process. So generally what we would do is we would specify a process ID to renice. So I would say the new niceness level is 10, and then I would, for example, say 2879. That would change the process priority for that one process. Well, the problem is I want to do this for every single HTTPD process. How do I do that? Well, that's very simple. All we have to do is our renice. We're going to set it as 10. And then we're going to open up what's called a subshell. And I do that by doing the $ open close parentheses. And inside of there, I'm going to execute a command. That command is going to be HTTPD. So what is going to happen is it's going to execute this command and then grep for all processes that are HTTPD in this subshell and pass it to our command here. So if I hit enter, you'll notice that for every running process ID, it has now changed that priority to 10. So we can now see that the process priority is set to 10. So hey, maybe we want to say, I need to have a higher priority, the highest priority possible for my HTTPD processes. So I can set that to 20. And I can now view all of them which have a process ID of 20. So let's create an example here. We have created our test.file. Now, if I were to do a time and then the command, I can actually see the time it takes to execute a specific command. And in fact, let me clear my screen so we can get started. What I want to do is I want to launch the tar program with a niceness level of 19, the lowest favorability or least favorable niceness we can give a process, which means it's not going to get priority from the CPU. Now this is going to vary on CPU intensive machines. Our lab server is probably not going to vary very much on this because we don't have a lot of other processes happening on our machine. So I'm going to set the nice level to 19 and my command is going to be tar. I'm going to create an archive and that archive name is going to be test.tar and it's going to be the test.file that we're going to add to that. So it's creating that archive and it's going to return how fast it executes this process. So if we see here how long it took to process it, well now let's launch this tar program with the most favorable niceness that we can do, which is -20. And let's see if that completes the process any quicker. Now it completes it a little bit quicker. Again, our example here is skewed not very favorable. The reason it's not going to show a big difference is because number one, I'm on a lab server. Number two, we're not really compressing that big of a file to make it a difference. But I just want to show that the example does demonstrate that's what the niceness does. It's saying that this process should get CPU processing priority from the CPU processor. Now, one thing to remember is that for privileged users, only privileged users, which are sudo users or root users, only those users have the ability to give a process more favor. For example, a regular user can decrease the favorability or the niceness by increasing the niceness number from, say, 20 to -19, but it can't say this process has more priority. Only privileged users can do that. So that's the niceness command, that's the renice command, and that's what nice does. We're going to take a look at this from another tool on how we can renice it called top. And in our next lesson, we're going to look at that as well as determining our load averages on our CPU processors. So that concludes it for this lesson. Go ahead and complete this lesson and move on.